Okay, so we're now just moving on to more worded questions. So let's have a look at these two word examples. So in word example one, what we're going to do is we're going to have a tick active approach, and then we're going to do a tick free. So I'm just going to read the paragraph at the top. It says, in this section it is shown how quadratics can be used to solve worded problems, including problems which involve finding the maximum or minimum value of a quadratic polynomial that has been used to model a practical situation. So for that maximum or minimum value, just remember if your dilation factor A is positive, then you've got a smiley face parabola, and then the minimum value will be this minimum turning point over here. And if your dilation factor is negative, then your turning point here will be a maximum value. All right, so if A is positive, that's always a minimum turning point. And if A is negative, then your turning point is always a maximum. Right, let's have a look at word example one. Jenny wishes to fence off a rectangular vegetable garden in her backyard. She has 20 meters of fencing wire, which she will use to fence 3 sides of the garden, with the existing timber fence forming the 4th side. Calculate the maximum area she can enclose. All right, so 3 sides of the enclosure will be made using the wire. And remember, we've got 20 meters of wire. So, as we discuss in class quite regularly, the best way to start a worded problem is always to sketch it out. See if you can put a diagram to what's given. So looking at the tick-free approach first, so this will be your garden. This is your wooden fence, and then the 3 wire fences over here. So defining the variables, of course, is very important, as you remember. So I said let the width of this enclosure be x, and then let the length be. So just think about this. If you've got a total length of 20 meters, then 20 meters taking the 2 sides, so minus x will give you this length, whatever's left over here. So the length is 20 minus 2x. So going back to the question, remember they want the maximum area. So you obviously need to build an equation for area. So always start by writing down the general form. So area is equal to length times width. Substitute in your expressions, and you can expand those brackets. And you can see, hey, what do I have here? I've got a quadratic. And the question was, what is the maximum area? So maximum area being a quadratic, our focus will be on the turning point. So this is an upside down turning point. So your dilation factor A here is negative, so it looks like this. So on the y-axis, you've got the area. On the x-axis, you've got the width, which we defined as x. Right, and we need to find that turning point. We do not have a calculator, so we're going to use our little turning point formula to find the x value of the turning point is minus b on 2a. And we substitute in our b, substitute in our a, and we get 5. In other words, the width of this is 5 meters. All right, sorry, your diagram here. The width here is 5 meters. And if that is 5, what is my maximum area? So we just take our x value, sub it into our quadratic equation, which is our area 1, and we get 50 meters squared. So remember your unit as 1 in the end. Okay, so what will it look like if this was in a tick active paper? In a tick active paper, initially, your thinking will be exactly the same. So you'll have to start by sketching it out. You'll have to define the variables. You have to write on the formula for area. You have to substitute it, and you have to get up to your quadratic equation. So you're going to get up to this point, it's the same. But because you've got your graphics calculator, you now do not need to follow an algebraic approach. You will go onto your graphics calculator graph mode. You will type the equation in. You will get your parabola, and you may have to zoom in here to see it. And then you're going to use gsolve. So gsolve max, and you'll see it gives you that pink cross on your screen there. So there's my maximum turning point when x is 5 and y will be 50. So interpreting it when x5, remember that's a width, and that will give you the maximum area of 50 squared meters. And also in a tech active paper, whatever you see on the calculator, you need to sketch. So just include a sketch graph of the parabola and just indicate the maximum turning point on it.